So the covariance measures the strength of the linear relationship between x and y. That's what it does. In a few minutes, I'll talk about correlation, as I said. And correlation is a number between -1 and 1. Actually, I can put the equation for it since I'm writing equations nice and neat. So I write the correlation. And the correlation, we use mu x comma y, and this will equal to the covariance, that's why we need the covariance of x and y, divided by sigma x times sigma y. And usually the correlation of x and y, it's a number between -1 and 1. And if the correlation is +1, that says we have a strong positive correlation. Meaning what? Again, let's go back to that washer. We've been talking about the washer, the thickness of the washer, and the hole. If the correlation between the thickness of the washer and the hole is plus 0.8, that says if the hole increases, it seems like the thickness also increases. There's a strong positive correlation. If we increase one, the other one increases. If we have a correlation of -1 or close to -1, that says if the size of the hole increases, guess what? The thickness is decreasing. So if one increases, the other ones decrease. If the correlation between them is very small or 0, that means there is no correlation. You can't predict what's going to happen next. That's what's nice about the correlation. You can predict if you see one thing happening. If I say, for example, people buying insurance, car insurance and home insurance from the same company. Usually there's a strong correlation. If you have home insurance with one company, guess what? Most likely you probably buy car insurance from the same company. So sometimes you see a positive correlation, maybe 0.8, 0.9. It says people who buy insurance from one company for their home, they buy the same, or car insurance from the same company. You see a negative correlation between satisfactions or dissatisfactions of a company. If the dissatisfaction factor is high, if you're not happy with the company, you're probably not going to recommend them, Or if one increases, the other one decreases. Again, if the time increases, maybe the temperature is going to decrease here. We're talking about some relation between time heating something up. Take a pipe, for example. That would be a good example. You want to heat the pipe. If you crank the temperature, do you need to leave it on more time or less time if the temperature increases? Less time. That's a negative correlation. As the temperature increases, time probably going to decrease. You're not going to leave it long, you'll melt it. As the temperature gets like 1,000, 2,000 degrees, you put on that pipe there and you let it sit there for 5 minutes, you make an axe, that thing is gone, melted. But we'll leave it there for less time now because that will heat it much faster. So that's a strong negative correlation. If one increases, the other one decreases. So that's where we're going with this. But to calculate the correlation, that's what we're interested in. We need to calculate the covariance. That's why it's the measure of the strength. And the larger that number, the larger the correlation is going to be. The smaller that number, the smaller the correlation is going to be. Now remember, sigma x and sigma y will never be negative. So that means the covariance could be positive, could be a negative number. It doesn't have to be between 0 and 1. The correlation has to be between 0 and 1. The covariance could be 10, 50, 70, if the standard deviation is high number 2. Notice, just for the sake of math, I don't really care what the topic is. You could have a covariance of 2004. As long as what? Sigma x maybe has a value of 700, and sigma y has a value of 400. Because when you divide them now, that correlation is going to be what? Less than 1. So this number does not have to be between 0 and 1. It depends on sigma x and sigma y. The ratio of that has to be between 0 and 1. I mean -1 and 1. We'll take an example on the covariance and correlation. I got to find mu xx and mu x and mu y, and do that to get the correlation. I need sigma x, I need sigma y to get the correlation. That's the covariance and correlation. That is the last thing actually I'm doing here with this chapter. And I will start, I am, as I said before, I'm 100% sure you'll see this on the final exam. You'll see these on the next test, which is Tuesday. We did an example last time, was X and Y, and I forgot what X represent.
The washer.
No, this is just discrete value. I got it. Let's say we're going to check some plywood, working for Home Depot. And we're going to count how many imperfections on that plywood. After you paint them. Now here's what happens when you're painting a piece of wood. The actual piece of wood could have a flaw in it, could have a bump in it, could have a knot, a hole in it. So the wood itself could be a problem. So when you look at them, you're counting how many of these problems on it. And when you paint them, if you use a cheap brush, what will happen?
Bristles.
Yeah, the bristles will fall and stick to that paint. So that's actually we making that. So let's make one of them is the actual flaw in that piece of wood. How many knots in it, how many holes, how many bumps in that wood. We'll call that X. And Y is foreign substance on that wood, could be again the brush, could be a dust got on it when you paint over it, that's going to stick to it. Now you made a mess on it. And let's say we have number 0, 1, 2. And for this, they don't have to be equal, but we'll make it equal. I just don't want to spend 6 hours on this.
Zeke, would you just find somewhere up there, rating imperfections?
Okay.
Because when you read them back on black
Yep.
paper, they sometimes don't make as much sense.
So we'll call this surface X represent the surface flaws. How is that? Makes sense on a piece of wood? On wood. Plywood, looking at plywood there. How many flaws in? And Y here, we'll say, I don't know, foreign particles on it after you paint it. Make sense? Again, could be dust, piece of dust, a hair fell off, not my head. A hair fell off, got stuck there, from the brush fell there and stuck to it. So we're counting how many flaws on that thing. And let's give you some probability. They have to add up to a 1. So we'll say 0.05, 10, 20 here. I'll go straight. If you want to write them, you don't have to look at the screen. So I'm going straight here. If you're going to write them without looking at the screen. So the next row now I'm going to start with 0.05, 0.15, 0.05, and the third row 0.25, 0.10, and 0.05. Now I need to get the marginal density functions or marginal probability. So the marginal one, this is piece of X here and piece of Y. So this one here is piece of Y. And let's add them. 5, 10, and 15, that's what? 35? 20, 25. Oh, that's 0.025, not 0.025. Where's my eraser here? I guess don't have any erasers. I'm not planning on making mistakes today. There we go. .25, 25, 35, 40, right? And piece of X here is going to be 5, 10, that's 35, 25, 35 again, and 30. So I can make them a separate function. Here's x and piece of x. X could have a value of 0, 1, 2. Probability, 0.35, 0.35, 0.30. Can I find mu x? It is the summation of what? X times piece of x. Remember that? So that's going to be 0 times 0.35 plus 1 times 0.35 plus 2 times 0.30. So what do we have? Uh, 0.35 plus 2 times 0.3, 0.95. While we add it, let's find sigma x. Let me do the variance first, before the square root. It's the summation of what? X squared times piece of x minus mu of x squared. Remember that one? So I got to square each x value. 0 squared is 0 times 0.35, 0 times 0.35. Plus 1 squared is 1 times 0.35 plus 2 squared, which is 4. 4 times 0.3. When you're done with that, subtract from it 0.95 squared. This is sigma x squared. I came up with, double check the numbers, as I said before. They don't come worse than me with calculators. I came up with 0.805. Anyone get that number? Take the square root of that number. Now I need to do it for y.
Quick question.
Yes.
The little chart with x and p of x and 0, 1, 2,
Yes.
1, 2, 5, that is called the marginal probability mass function?
Correct.
Okay.
But because when you say function, that's the only one I have problem with. Function, usually that's reserved for continuous.
Yeah.
But I know what you're saying. Yep.
That was just, yeah,
Yep.
in this book, in one of the problems, they
Yep.
asked for that.
I guess that.
That's the marginal, yes. It is the marginal
It's the marginal probability.
function. Or it's not a function because it's discrete, you know? So the word function is bugging me, yeah, but I know what he's saying. Like when it's continuous, it's called marginal density function. That's what it's called, you know? So now, piece of y. Let's look at that. What's my piece of y? Here's the numbers. Y and piece of y. Y, let's see, can I have a value of 0, and the probability for that is 0.35. A value of 1, 0.25. A value of 2, 0.40. Again, repeat the process. What is mu x? Mu y, I'm sorry. Mu y is the summation of y times piece of y. So that will be 0 times 0.35 plus 1 times 0.25 plus 2 times 0.40. 0.8 plus 0.25, is that 1.05, I think? And what is sigma y? Sigma y squared, let's do the variance, is the summation of y squared times piece of y minus mu y squared. So it's going to be 0 squared, which is 0, times 0.35 plus 1 squared, which is 1 times 0.25, plus 2 squared, which is 4 times 0.4, minus 1.05 squared. 1.6 plus 0.25 minus 1.05 squared. So sigma y squared equals 0.7475, which means sigma y is the square root of that number. 0.865 roughly. Now I'm almost done to give you the covariance and correlation. But here's one little problem. I know what mu x and I know what mu y is, so but I don't know what mu x y. Once I have that, I'm done. I can tell you the covariance. I get sigma x, sigma y, I can tell you the correlation. So the only thing standing in my way is this guy. How do we find mu x y?
X times Y times probability.
Yes, that's absolutely correct. I'll do it on a separate page here just so I can leave. Just let me make sure my notes are from last class, not messed up with this. Okay, that's good.
We're finding the covariance now?
Not yet. I need to find mu x y.
Well, we're going to use the equation with the sigmas.
What's mu x y? Did I write that mu x y? I don't know. How did we write that? Mu x y. I wrote it this way. How do we find that? It is the summation of what? X times y times the probability of x, y. Ready for that? Here we go. I'll just put the answer, otherwise it gets really long. 0 times 0 times 0.05, which is what?
0.
So you multiply x times y times the probability, that's a 0. Plus 1 times 0 times 0.1. Another 0, right? Plus 2 times 0 times 0.2. So if you, the problem with that, if you look at the notes, you won't know what that is, so maybe I shouldn't write it like this. Maybe I should just write the stuff down. Because if somebody just looking at the notes, they go, what is the 0? So it's 0 times 0 times 0.05 plus 0 times 1 times 0.10 plus 0 times 2 times 0.20 plus 1 times 0 times 0.05 plus 1 times 1 times 0.15 plus 1 times 2 times 0.05 plus 2 times 0 times 0.025 plus 2 times 1 times 0.10 plus finally 2 times 2 times 0.05. That's how you're going to find it. The good news, a lot of these going to be 0, right? So this one is 0. This one is 0. This one is 0. It makes my math easy. This one is 0. This one is 0. Any more zeros? No. So what are we going to have? 1 times 1 is 1 times 0.15? 0.15. 1 times 2 is 2 times 0.05 is 0.10. 0.20. 0.20. 20, 40, 50, 65.
Then that gives us a negative covariance?
Could be.
Oh, so that is fine to have a negative covariance?
Yep.
Okay.
So what is my covariance now? It's mu xy minus mu x times mu y. It's 0.65 times, minus, not times, minus mu x. What's mu x? I did that. 0.95. And mu y, I think 1.05. Was it 1.05? So we have a negative covariance. Negative 0.3475. Your covariance could be positive, could be negative, could be less than 1, could be more than 1, could be hundreds. Correlation of x comma y is equal to the covariance of xy divided by sigma x, sigma y.
So the correlation is indicated by that row?
You take this one, divided by sigma x and sigma y.
Now how do you write, like covariance is COV?
Yep. Correlation, that row, yes.
And the row is
Row.
what?
Correlation. Notice right here, correlation. correlation. It's the row. Yep. Not a P, it's row, yeah. So now, I know my covariance here, negative 0.3475. Sigma x, I did this for this problem, 0.805. And sigma y, I have it, 0.865. So negative 0.3475 divided by, you're going to multiply these, 0.805 times, make sure you put the two numbers in the bottom in parentheses. Order of operations on the calculator. And roughly negative 0.5. You're on the bubble there. It's a negative correlation, meaning one increase, the other one decrease. But you're on the bubble, meaning what? If it was a minus 1, that's a strong negative correlation. If it's plus 1, is a strong positive correlation. Once you get 0.5, between negative 0.5 and 0.5, it's really not much of a correlation. It's hard to tell if there's 0 means there's definitely no correlation. You can't predict. But the 0.5, you're between, there might be a chance that if this has more, this will have less. Or if this has less, this will have more. But you're right there. You're not actually strong. You're not 0. You are weak negative correlation. It's not a strong correlation. This number is always between negative 1 and 1. Negative 1, when it's close to 1, that's a strong correlation. When it's close to 0, that's a weak correlation or no correlation. So that's how you do correlation, covariance. I always try to do something first with discrete. It's easier to see that. Now let's switch that to continuous function. And it's the same thing. But the math gets a little bit fun now. You start doing integration, double integral here. Now, if you get 0 correlation, that means absolutely there's no correlation. But you get 0, that means definitely there's no correlation. So that means they're independent. Whatever happens in one has nothing to do with the other one. That's really one way of looking at it. The events are independent. Doesn't matter what happens here. it doesn't affect the other one. But when you get like toward the 1, that means when one increased, the other one decreased. That can't be independent. One affects the other one, that becomes dependent.
What if it is 0.5?
They still depend, it's still affecting a little bit. So it's to be independent means I don't care what happens there, will never affect this one. So the only way to prove that's independent if actually your covariance is 0, which means the correlation is 0. Because if the covariance is 0, 0 divided by anything is 0.
If it is 0.1.
No, there's still small effect. It's maybe not a lot.
Yep.
I studied extra 10 minutes on the test, and I don't know if it's going to help me or not. That kind of a thing. For example, let's say you have a test on history, and you go and memorize everything. You study for 60 hours, memorize every single event. You should do well on that test. There's strong correlation. The number of hours you put in there is going to help you on the test. But if you study 10 minutes, you can't really see anything. If they give you a question on the stuff you studied, that might help you. But we're not sure if it's going to be there or not.
So they're independent only if rho
Zero.
is 0.
Correct. So now let's take one continuous here. Let's see if I can take an example. Oh, you know what? A few weeks ago we did the problem. I like that problem. We had a function that looked like this. Let me change color. I don't like the red color before. It was 8xy. And we said this is when x and y belong to A. In this section, I'll draw the picture there, has a value of 0 otherwise. Does not belong to A. And what it was a graph we did. Where's my ruler here? Missing a ruler. This is y equals to x. This is 1 here, and this is 1. And this area where you need to be. This is A. So you got to be in that area. As long as you're in that, we're going to use that function. I can't remember what that example was, the topic, when we did it.
It was the signals processing.
Yeah, the delay, the time, I think, between x and y. How long? Something like that, but it doesn't really matter. Some story we did there with it. So I want to find the covariance for that. And I'll do the correlation. What's the covariance of x comma y? Again, it is mu xy minus mu x mu y. I could just ask this question on the test, and it sounds like, I don't know, or you know what? On the test, I could find the correlation. And really, there's about 10 things to this problem to do. That little question, we'll have like 10 little pieces to do. And you'll see some of them. The first one, what's mu xy? That's an easy one. But what's mu x? What's mu y? Well, guess what? To find mu x, if you remember, it's what? It's the integral, instead of summation, of x times f of xx. To find mu y, negative infinity to infinity, you probably have these in your notes from last time, right? I left mine in my office. I meant to bring it. So that means before I do anything, before we touch anything, I need to go find f of xx and f of yy. Now, we did that example before, but I'll pretend we didn't do it, because on the test I'm going to give you a new problem. You didn't see. So let's find f of xx. Look at your notes. What did we say to find f of xx? What was the equation?
Integral from negative infinity to infinity of f of xy dy.
Correct.
The limits are actually whatever the range is for your value, right?
Except we gotta be careful here. You integrate with respect to y. Yes. So you have to go to this one, and the y value is going from where to where? Let's look at this. So my function is 8xy. If you cut this into strips, just to show you, if you take this and cut it into strips, where are you going? From where to where? 0 to x, exactly. You're not going all the way to 1. A lot of people want to write 0 to 1. You're not going to 1 because you're operating in that area. You can see where each piece is ending. From here to there, which is y. And y, you want your answer as a function of x. You're not going to put y if you want it as a function of x. So this should be from 0 to x. Everyone see that? Integrate that, that will give me what? I think we did this problem, but I'll pretend we didn't do it. 4 x, what is it, y squared, right? And from 0 to x, and that will be 4x cubed. Yes. So f of x equals 4x cubed, as x goes from where to where? From 0 to 1. You can see it from 0 to 1. Now I need to find f of y. Again, the definition in your notes, from negative infinity to infinity, f of x comma y dx. Now let's look at this. I'll leave that one there. We're going to be taking strips. When you're calculating that, you're going to be going from here to there, to here, to here. See where you're starting from? You're not starting from 1. You're not starting from 0. You're ending at 1. So I know my upper limit is going to be from where to where. So this is going to be 1 here. You're going to start with x, but you want to function as a function of y. Yes, from y to 1. And I made them in different color intentionally so you get to see them. So that will give me 4x squared y. X going from y to x equals 1. At the upper limit, that's what? 4x squared? 4y. I'm sorry, not x squared, right? 4y. X is 1. 4y minus, when x equals y, that would be what? Is it 4y cubed? So what's f of y? It's 4y minus y cubed. And y is also going from 0 to 1. I got to make sure I don't lose these papers now. Now I'm going to find mu x and mu y. Maybe I'll do them on this page, but I still have some room on each one. Here's what mu x is. X times f of x. So let me, mu y is y times f of y. So let me come back here. I'll change color. And you want to find mu y? It's the integral from negative infinity to infinity of y times f of y. And y is going from 0 to 1. So from 0 to 1, 4y squared minus 4y to the 4th dy. Notice for my function, y go from 0 to 1. So when I get to this one, I got to integrate from 0 to 1. I don't look back at the area. That's where it's good from. So when y is 1, what do we have? 4. Is that a 0? Looks like we got a 0 on that one, right? That would be a 0. Because you integrate that, that's 4/3 y cubed minus what? 4/5. No, maybe that's not 0. What am I saying 0? 4/5 y to what power? 5? From 0 to 1. So it's 4/3 minus 4/5. If you want to add or subtract, LCD is 15. 4, that would be 5 times 4, which is 20. 3 times 4 is 12. What do we have? 8/15? So that's what mu y.
So we'll just do the same thing again with
X, correct.
From 0 to 1.
Yep. So I'm trying to make sure my pages stay clean, knowing where each page goes. So let me bring this one down. Mu x equals the integral from negative infinity to infinity of x times f of xx. From 0 to 1, and this will be what? 4x to the 4th dx. That will give me 4x to the 5/5 from 0 to 1, and that's 4/5. What is it?
4x to the 3?
That's 5.
No, f of x.
Yeah, but times x,
Oh, no,
right? X times f of x. So the 4x to the 4th,
Yeah.
and you add 1 to the power, divide by the new power. Now we find mu x. So here's the good news, bad news. Depends how we look at it. We found these two, but we still have to find that one. So I will go back now and find mu xy. I'll let you finish it first.
Do we have to do a double integral?
Yes, you do. Double integral. Jake just said, do you have to do double integral? I said, yep. Because if you look at the discrete, the way we did the discrete, to find this one, we did x times y. It really should have been double summation, but x times y. You multiply x and y in this, so you have two functions. So you get a double integral for that one. Okay. So make sure the pages stay on the right. So now, what is mu xy? That's a double integral of x times y times f of x comma y. You want to do dy first and dx? That's fine. Now remember, you're looking for a number. So the first one, if you're going to do with respect to y, x goes from 0 to 1.
0 to x.
0 to x. Very good. Good job. Bernsey will be happy. I'll tell him that today. So you did a good job, Burns. So you do the math, that's what? 8x squared, y squared? Integrate with respect to y first. 8/3 x squared y cubed, y going from 0 to x, that'll make it x cubed, that's x to the 5th. Integrate that, that's what? 8 over 3 times 6, 18, x to the 6, x going from 0 to 1. Is it 8 over 16? Can we simplify 8 over 16?
Over 18. Yeah, over 18.
8 over 18, I was at 16, yep. We can divide by what? By 2? 4 nines. What's the covariance of x comma y? It's going to be 4 over 9 minus mu x. Where is mu x?
Where do we find a numerical value?
4 over 5 times mu y, which is what? 8 over 15. Four over 9 minus 4 times 8 is what? 32 over 5 times 15 is that 75. So if I cheat here, LCD probably 9 times 75, which is, who knows, 225, 445, some number. But it's 4 divided by 9 minus 32 divided by 75. We get calculators here. The covariance here is what? 0.017 or 18. Notice the strength of that relationship is not strong. It's a weak relationship. The number is very small.
So basically independent?
Well, to use the word independent has to be exactly 0. So I would say not a strong relationship, but it's not really independent. Independent means nothing effect.
Is near independent a phrase?
What is it?
Near independent?
I won't use the word. I would just say weak relationship. You know. Think of independent like doing taxes. If it's not your kid, can't claim it. So, well, you know, he lives over, he comes over all the time, I feed him, he hangs out with my son, I buy him clothes, I take him to the games. Not your kid. You know, if it's not 0, it's not independent. Almost your child, but it's not really your kid, you know. He comes over all the time. Okay. What about if I want to find the covariance for the same problem? I mean, correlation of the covariance. We're asking for more work now. Let's see. That'll be the last thing today. What time is it? Oh, God. I need sigma x. So how do we find sigma x? Well, before I get to sigma x, let's do the variance. What is the variance squared? Remember when we did this problem in discrete, let me just take you back, refresh your memory. Sigma x is the summation of what? X squared times px. See that? That means the integral, negative infinity to infinity, of x squared times f of xx dx minus what? Mu x squared. Same equation, except this becomes integral. As I say, I can ask one question, seems like I'm a nice guy, and you'll have like 10 parts to it. So now you got to go and find your integral for sigma x. X is going from 0 to 1. X squared, let me look through my notes, find where f of xx is. What was it? 4x cubed. Minus, I know what mu x, I found it for that problem. Mu x was 4 over 5, and I got to square it. Then I got to take the square root of the whole answer. This is 4x to the 5th. What's that, 16 over 25? So that's 4 over 6, x to the 6, over 6 minus 16 over 25. Go to calculator now. Make my life easy. Divided by 6 minus 16 divided by 25. I came up with sigma x squared equals 0.027. What is sigma x equal to? The square root of that number. .163. One more and we're done. Bring your lunchbox with you on Tuesday for the test. This is one question. What's sigma y squared? It's the integral from 0 to 1 again of y squared f of y dy minus mu y squared. Zero to 1. And if I remember, my f of y was it 4? Was it y minus y cubed?
Yeah.
And again, I gotta look through my notes and see what was f of what was mu y. 8 over 15. So that's the integral from 0 to 1 of 4y cubed minus 4y to the 5th, I think, right? dy. 8 times 8, 64. 15 times 15, is it 225? Integrate that. Oh, that becomes what? Y to the 4th? This will be 4 over 6, which is what? 2 over 3. Y to the 6 from 0 to 1. Well, you don't like that one, John? I was,
No, no, negative.
So 1 minus, that's a 1/3, right? 1 divided by 3 minus 64 divided by 225. I came up with 0.049. So what's sigma y? Square root of that number. 0.221. Now I am done. We found the covariance early, right? What is the correlation of x comma y? It's the covariance of x comma y over sigma x times sigma y. What's my covariance? I gotta look through 3, 4, 5, 6 pages. I found the covariance, 0.018. And what's sigma x? 0.163. What's sigma y? 0.221. Do the math. Let's see what we have for correlation. 0.018 divided by 0.163 divided by 0.221. 0.5 again. Positive 0.5 again. That's really a weak correlation. I can't tell you the relationship between X and Y. It's not positive. I know it's positive, but it's a weak positive relation, not a strong one.
When would you say that it's a strong correlation? What is the trend?
I would say like 0.7 higher, 0.8 higher. You get 0.8 and higher, that's definitely a strong correlation, positive. Negative 0.8 to negative 0.1, and negative 1, that's a strong negative 1. When you start to get 0.5, 0.6, you're on the bubble, close to 0, no correlation.
Is it almost like think of it sort of like an exponential function that between half and negative half, you really can't say there's anything, but once you start passing that mark, you can more and more say that there, just at the tail of it, you can say like, yeah, there is a correlation, but in the middle of it, there's not.
I don't know if it's just because it's quadratic. I know you're looking at the graph like this. Let me stop the camera because these notes are nice and clean. I don't want to ruin